Problem 20. Evaluate the limit as x goes to pi over 2 from the left of cosine to the 1 minus sine x of x. First, we want to rewrite this. I don't like seeing this strange exponent here inside the cosine function. So we can rewrite this as the limit as x goes to pi over 2 from the left of cosine of x, because our angle is x, raised to the power of 1 minus sine x. Now, if we were to try this by direct substitution, the cosine of pi over 2 is 0, raised to the power of 1 minus sine of pi over 2 is 1. So we get 0 to the 0, which is an indeterminate form. So in particular, we need to solve this problem by using logs. Let's go back to the original and replace this with y equals the limit as x goes to pi over 2 of cosine to the 1 minus sine xx. So we'll start this by taking the natural log of both sides of this equation. So we've got the natural log of y equals the natural log of the limit x goes to pi over 2 from the left. And then we've got the natural, because the natural log is continuous, we can bring it inside the limit. So this becomes natural log of cosine x to the 1 minus sine x. The reason behind doing this is so now we can take this power, this 1 minus sine x, and bring it out in front of the log. So we rewrite this as the limit x goes to pi over 2 from the left of 1 minus sine x times the natural log of cosine x. Now, trying this by direct substitution again, we get 1 minus sine of pi over 2, which is 0, times the natural log of cosine pi over 2, remember, is 0, so this looks like 0 times negative infinity. When this happens, we want to take the simpler term, in this case the one without the logarithm, and move it to the denominator. So we can rewrite this as the limit as x goes to pi over 2 from the left of natural log cosine x divided by 1 minus sine x to the negative 1. And now if we try this by direct substitution, we've got what looks like infinity over infinity. So we can finally use L'Hopital's rule. So we'll rewrite the limit. Limit as x goes to pi over 2 from the left. And then we take the derivative of both numerator and denominator. So the derivative of the numerator gives us 1 over cosine x times the derivative of cosine x is negative sine x. Now in our denominator, we take the derivative by using the power rule. So we've got negative 1 times 1 minus sine x to the negative 2 times the derivative of the inside. The derivative of 1 minus sine x is negative cosine x. Now let's rewrite this without all these fractions in place. So this becomes the limit as x goes to pi over 2 from the left of negative sine x. That was what we had in the numerator already. This negative exponent will bring up to the numerator, where it becomes 1 minus sine x squared divided by, now this 1 over cosine x, we'll move this to the denominator as a cosine x, where it'll join this cosine x that's already here, so times cosine x. And I see that the denominator, we've got a negative times another negative, so the negative signs cancel, leaving us just this. If we try this again by direct substitution, we've got sine of pi over 2, which is 1. Sine of pi over 2 is 1, so this gives us 0 squared. In our denominator, cosine of 0 is 0, and cosine of 0 is 0. So it's still of the form 0 over 0. So we want to maybe try L'Hopital's rule again. But this is starting to look really ugly. So let's maybe simplify this limit a little bit by breaking this into separate pieces. We'll write this as limit as x goes to pi over 2 from the left of negative sine x times the limit as x goes to pi over 2 from the left of 1 minus sine x over cosine x times a second 1 minus sine x over cosine x. And now we'll evaluate each limit independently. So for this first limit, we'll try this by direct substitution. Sine of pi over 2 is 1. So this gives us -1 for our first limit. On the second piece, if we try this by direct substitution, we get 0 over 0. So maybe we'll try L'Hopital's rule here. So we evaluate the second limit by L'Hopital, and we've got the limit as x goes to pi over 2 from the left. The derivative of the numerator is negative cosine x. The derivative of the denominator is negative sine x. And if we try this by direct substitution, we've got cosine of pi over 2 is 0, sine of pi over 2 is 1, and we're squaring this, and so we get 0. However, remember that all of this was equal to the natural log of y. So we'll rewrite this equation. Natural log of y equals 0. Then we exponentiate both sides. This tells us that y is equal to e to the 0, which is 1. That says that the original limit evaluates to 1.